You might be finding decomposition reactions, predicting the products for decomposition reactions, to be a little more difficult than the other types of reactions, and that's probably accurate. So we have this table here that's going to guide us, so it'll make it a lot easier to organize our knowledge. So in this video, we'll look at the decomposition of binary compounds, carbonates, hydroxides, chlorates, and oxides, and these are the major ones we need to know. So let's get started with some binary compounds. See how they decompose. So when we say binary compounds, we mean like NaCl, MgBr2, maybe H2O, just two different types of elements, no polyatomic ions. And the pattern is, in this case, A would be sodium, B is chlorine, they break apart, and we're going to get Na and Cl. And that seems pretty easy, but we're not quite done yet. You can have just one chlorine atom bonded to another atom, but when it's alone, it's always going to be Cl2. It's called a diatomic gas. You really need to remember these. Here are the major ones. Here's our chlorine. These are the other ones. Commit this to memory. It comes up all the time in chemistry. One way you can do that is with this little mnemonic. Probably not the best K through 12 mnemonic, but have no fear of ice cold beer. H2, N2, F2, O2, I2, we have our Cl2, and then our Br2. So if you know that, you'll be able to remember these diatomics pretty easily. All right, back to the decomposition reactions. So remembering those diatomics, pause and figure out what we get when CaCl2 undergoes decomposition. So we'll have our Ca, and then we'll have our Cl. But remember, it's Cl2 because it's a diatomic gas. Note, I'm not going to balance these reactions here in this video, and I'm not going to write the states. We don't need that information to predict the products. But if your teacher requires it, you'd better write it down. Okay, pause and give this one a try. And remember our mnemonic, hydrogen, H2, oxygen is going to be O2. So that's how it works with the binary ionic compounds. And understand, this isn't dissolving. This is a solid and it's breaking down. We don't have any water involved, so this isn't just dissolving. It's breaking apart. The gas, the chlorine gas, it'll actually leave. We'll be left with solid sodium. Often these here are done with electricity to make it happen, so we have to put energy in to break these down. Okay, let's try our next category. For carbonates, we have the metal, that's the Mg here, and CO3, this is the carbonate. It is a polyatomic ion. So when this breaks down, we get the metal, that's the Mg plus oxygen. So MgO, and then we have carbon dioxide with that. So carbonates, they break down into the metal oxide and carbon dioxide. So pause, give this one a try. So we'll have our metal, that's the sodium, and then we'll have the oxygen with that, so NaO plus the carbon dioxide. And this seems like a pretty reasonable answer, except it's not quite right. We need to look at the charge here. We have a metal and a nonmetal. We need to make sure the charge is balanced. For Mg, that forms 2+ ions, and oxygen is always 2-. Down here, though, let's look at the periodic table. We have sodium. This is group 1. All of these are 1+. Here's sodium. That's going to be 1+. All of these form 2+ ions. Skip the transition metal, 3+, 4+, 4-, and then we go 3-, 2-, 1-, and 0. Here's oxygen right here, 2-. So remember, sodium's 1+, oxygen's 2-. So we have our 1+ and our 2-, and you can see we're going to need 2 of the sodium atoms there to balance the charge. So it's Na2O. Always got to watch for charge when you have a metal and a nonmetal. With the carbonates, you're always going to have to do this. Let's try one last one. Looks a little bit tough, but follow the pattern. See how aluminum carbonate decomposes. So the metal is aluminum, and we'll put an oxygen with that, plus CO2. So that's the first part. And then aluminum, if we look at the periodic table, that's 3+, and oxygen's always 2-. And here what I'll do is use the crisscross method here. I'll move the 3 here and the 2 here, get rid of these. charge balances out, and we're done. Need help with that crisscross method? There's a link in the description of this video. So those are the products of the decomposition reaction. All right, let's go on and do hydroxides. So for hydroxides, we have our metal, that's the calcium here, and then the OH, this is called a hydroxide ion. It has a 1- charge, so it always has a 1- charge on it. And then we'll have our metal over here with oxygen, and then we'll have water. So we're going to take our calcium, then we have an oxygen with that, plus water. And that's how it works. Let's check our charge though. Calcium's right here in group 2, that's 2+. Oxygen, right here, oxygen's always 2-. That balances out, so we're good. We can leave it like this. So pause and predict the products for the decomposition of KOH. And potassium, that's in group 1 with sodium, so it has a 1+ ionic charge. So we have our metal, that's the K. We put an oxygen with it like it shows us there, plus the water. And we said oxygen, we know that's always 2-. 1+ here for the potassium, so we'll need 2 of those, K2O plus H2O. That's it. All right, one last one. Predict the products here for the decomposition of aluminum hydroxide. Remember, aluminum 3+, that's its ionic charge. So aluminum, and then we have oxygen, so ALO, plus the water there, and then we've got to worry about charge. So aluminum is 3+, oxygen is 2-. Let's just cross them. So now the charge cancels out, and that's the products of this hydroxide decomposing. Again, it's not balanced, and we didn't write the states, but we don't need that to predict the identity of the compounds we end up with. All right, let's try some more. We're getting there, and we have some practice at the end. We're getting there. Let's do the chlorates here. M, that's our metal, and this ClO3, that's the chlorate, has a 1- ionic charge. So sodium, that's going to give us the Na, plus we have our chlorine attached to the Na, so we have NaCl, and then we just add O2 on the end of that. We're done. Sodium, that's 1+, chlorine's 1-, so we're good. We can leave it like that. Pause and give this one a try. Note that calcium, that forms 2+ ions. It's in group 2. So the metal, that's the calcium, and next to the metal we put the chlorine, and then we have oxygen gas. In this case we said 2+, 1-, so we're going to need 2 chlorines there to balance that out. All right, let's take a look at metal oxides. That's going to be the last category we look at here. Then I'll give you a chance to practice some. So here we have our metal, that's the iron, and then oxygen, metal oxide. And we get the metal by itself, so just Fe. And we can do that, just have solid iron. We can have an element all by itself, and plus O2. That's it. That's not too bad. It's not balanced, but these are the right products. Pause, give this one a try. So we have our metal oxide, we get our metal, that calcium metal, plus O2. Done. Let's do one more. These are easy. Pause, give that one a try. So the potassium oxide, that decomposes into the metal, the potassium plus oxygen gas. That's it. So we have our 5 categories here, and one of each is over here. So predict the products of these here, and let me give you the periodic table and hide those categories for you. Give this a try. Pause and see if you can get these all correct. So these are the answers. If you had a problem with that, go back, identify where you had this problem, or maybe later, give these practice problems another try. Next up, we're going to look at combination reactions, and that's kind of nice because it's just the reverse of what we did here. This is Dr. B. Thanks for watching.